Welcome back. In the last video, we discussed a few things of what our training setup is missing. And those things are probably what's contributing towards our results not as being as good as the results that the original Vision Transformer got in the paper. And the main one being scale. So let's just write here. The main things our training implementation is missing. Data. Our setup uses far less data, e.g. we only have 225 training images versus millions for the Vision Transformer. And then we have, so that would be probably the first thing that I would increase or to improve our setup is to add more data. And of course, if you wanted to, you could go into Torch Vision datasets, download the entire Food 101 dataset. This is an extension you can try out, and if you do, please let me know in the GitHub discussions. I'd love to see it. And then there was a few techniques, such as gradient clipping. So gradient clipping is prevent gradients from getting too big. And in fact, a few techniques I tried before that, and that's learning rate warm-up and then learning rate decay. So these three, I'm just going to write here, prevent underfitting, which is more data technique usually, and these prevent overfitting. So learning rate warm up, start with a low learning rate and increase to a base learning rate, and then learning rate decay as your model gets closer to convergence. Start to lower the learning rate. So just like when you're reaching for a coin at the back of a couch, the closer and closer you get to that coin, you want to take smaller and smaller steps. That's the idea of learning rate decay. Now, if you wanted to find out more about these, you can always search PyTorch technique name, such as PyTorch learning rate decay, and see what comes up. There's plenty of guides for that. But we've talked about underfitting and overfitting. Let's now see, we can kind of infer what our model is doing in terms of underfitting, plotting loss curves for our model. One of the best ways to see if a model is underfitting or overfitting is to plot a loss curve. So let's do that for our ViT model. So from helper functions, import plot loss curves, and we can go plot loss curves on results. It's going to give us, oh, what did we get? Typo here. Did you catch that? Oh, okay. So our loss curves are kind of all over the place. At least the training loss is going down, but then it kind of flattens out. The test loss is, well, we've got a mountain of test loss. We want that mountain to be the other way. And then the accuracy, well, there's not really much going on there either. Now, these could improve if we increased the amount of training time, but what do you think? Is our model overfitting or underfitting? Overfitting or underfitting? Well, it's actually quite hard to tell. But for me, I would say that it's dramatically underfitting, and it's also overfitting because the training loss goes down and the test loss stays up. Recall that the ideal model, or the Goldilocks model, is that the loss and training or train and test loss go down in a similar fashion. And do you recall the technique that we used in section 6, and it's kind of revealing itself here, which helps to deal with overfitting and both helps to deal with underfitting. Transfer learning. And then we have transfer learning as well. So we've got some loss curves here where our model is basically underfitting and overfitting. What do you think could improve this? We could, of course, try with more data, but what if we didn't really have more data? What if we were stuck where we're working on Food Vision Mini and the company or the startup we're working for is like, well, we've only got 225 images. What are the best results you can get with just those images? Well, the technique I'd be looking to use is transfer learning. So that's what we're going to cover in the next subsequent videos, but you might want to give this a shot yourself before we do. So all the techniques that we're going to use are in PyTorch transfer learning. See if you can make a feature extractor model using, let's go to Torch Vision. Let's find out, is there a pre-trained Vision Transformer here? We've built our own from scratch, but perhaps we want to look for a pre-trained one. So we'll come down to classification models, Vision Transformer. Here we go. Okay. We're on a bit of a roll here. ViT B16. That's the model that we built. So, all right. We can use ViT B16 weights. So they're going to be trained on ImageNet 1K V1. Okay, so it gets some pretty good results. These weights were trained from scratch by using a modified version of DEETS. So that's Data Efficient Vision Transformer training recipe. And the accuracy at 1 on ImageNet 1K is 81%. So that's on 1,000 classes. And the image size is 224, 224. Okay, well, my challenge to you is to see if you can use these weights and train a feature extractor model on our Food Vision mini data. And again, we created a feature extraction model here. If we search for feature extractor, there we go. Setting up a pre-trained model. So the steps will be very similar to what we followed here, except we're going to use, or you're going to use, Torch Vision Models ViT B16. So give that a go, and we'll cover it in the next video. I'll see you there.